Download this code from codegive.com, link in the description below. OK, let's delve into the fascinating and often frustrating world of Bedrock Edition, Minecraft, Bedrock Edition, specifically the scripting API, and how you can inadvertently create bed monsters, unexpected and undesirable behaviors, by misusing scope in your code. We'll cover the concept of scope, its importance in Bedrock scripting, common pitfalls leading to scope-related issues, and provide practical code examples to illustrate these problems and how to fix them. Understanding scope in Bedrock scripting, and programming in general. Scope, in essence, defines the visibility and lifetime of variables, functions, and other entities within your code. Think of it like this: a variable's scope determines which parts of your code can access and modify it. If a variable is out of scope for a particular function, that function simply can't see or interact with it. Why is this important? Proper scope management is crucial for several reasons. Avoiding naming conflicts. Imagine you have two different scripts, each using a variable named player health. If these variables have global scope, they'll clash, leading to unpredictable results. Scope helps keep variables separate and prevents these conflicts. Encapsulation and modularity. Scope allows you to encapsulate parts of your code, preventing unintended modifications from other parts of your script. This makes your code more modular, easier to understand, and less prone to bugs. It's like having private rooms in a house, only specific people can enter them. Memory management. Variables only exist in memory as long as they are in scope. Once a variable goes out of scope, the memory it occupies can be reclaimed. This is especially important in resource-constrained environments, although less of a direct concern in Bedrock compared to some other programming contexts. Types of scope in Bedrock scripting. Bedrock scripting primarily uses two main types of scope. 1. Global scope. Variables declared outside of any function have global scope. They are accessible from anywhere in your script. 2. Local scope. Function scope/block scope. Variables declared inside a function, or sometimes within a block of code, like a loop or if statement, have local scope. They are only accessible within that function, or block. Common pitfalls, creating the bed monsters. Here's where the trouble begins. Misunderstanding or incorrectly using scope can lead to unexpected behavior and difficult to debug problems. Here are some common scenarios. Accidental global variables. The worst offender forgetting to declare a variable with let or const inside a function will inadvertently create a global variable. This is a very common mistake, and it can have far-reaching consequences. Closure issues. Advanced, but important closures occur when a function remembers variables from its surrounding scope even after that scope has supposedly ended. This can lead to unexpected values if you're not careful. Conflicting variable names. The silent killer declaring variables with the same name in different scopes can lead to confusion and incorrect behavior if you're not careful about which variable you're accessing. Asynchronous operations. Async problems. When dealing with asynchronous operations, like network requests or timers, the scope within a callback function can be tricky. If you're not careful, you might be trying to access a variable that no longer exists, or has a different value than you expect. Illustrative code examples, with bed monsters, and solutions. Let's look at some code examples that demonstrate these pitfalls and how to fix them. We'll use examples that manipulate player data because those are common scenarios in Bedrock scripting. I'll assume you have a basic understanding of Bedrock scripting and how to create behavior packs. Example 1, the health stealing monster, accidental global. The problem Asterisk the intention is likely to have each player keep track of their own health independently. However, because current health is declared globally and the function update health modifies it without declaring it in its scope, all players will share the same health value. When one player gets hit, it will impact every player. This is a bad bed monster. The solution asterisk. Or if you wanted to use the global health variable. Explanation asterisk. Asterisk by declaring let current health equals 20, inside the update health function, we create a local variable. Each time the function is called, it has its own independent current health variable. Now the health does not persist between calls because the scope of current health is only within the function of update health. Important note asterisk in the Bedrock scripting API, a better approach is to use entity components to store player-specific data. This ensures data is tied to the entity and persists across script reloads, and potentially across world saves. Here's how you'd do that using components. Explanation asterisk. Asterisk entity.add component, health identifier, asterisk adds a custom health component to the entity, similar to how you add generic components. Asterisk entity.get component, health identifier, asterisk retrieves the custom health component. Asterisk using the component for storage asterisk now health is stored with the entity, persists through script reloads, and is easier to manage. Example 2, the delayed explosion monster, closure issues. The problem asterisk. Asterisk the intention is to create 5 different chat event listeners, each applying a different poison duration based on the loop counter I. However, because JavaScript closures capture variables by reference, all the event listeners end up using the final value of I, which is 5, when the chat event eventually triggers. This is because by the time any of the chat events are even triggered, I will already have hit its end value. The solution asterisk. Explanation asterisk. Asterisk we wrap the event listener creation in an immediately invoked function expression, IIFE. Asterisk the IIFE takes I as an argument, which we've renamed to index for clarity. Asterisk inside the IIFE, index is a local variable that captures a copy of the current value of I at the time the IIFE is executed. Asterisk now, each event listener has its own index variable, holding the correct value. Example 3, the conflicting variable names monster. The problem asterisk. Asterisk there are 2 variables named score, one global and one local to the update score function. Asterisk inside the function, when you refer to score, you're referring to the local variable, not the global one, unless you explicitly refer to the global scope using this .score. The solution asterisk. Explanation asterisk. Asterisk by renaming the local variable to local score, we eliminate the naming conflict. Now, when we refer to score inside the function, it correctly refers to the global variable. Best practices for managing scope. Asterisk always declare variables asterisk use let or const to explicitly declare variables within the scope you intend. Avoid implicit globals. Asterisk use const when possible asterisk const creates variables that cannot be reassigned. This helps prevent accidental modifications and makes your code easier to reason about. Asterisk minimize global variables asterisk global variables can make your code harder to maintain and debug. Strive to keep variables as local as possible. Use entity components to store per entity data. Asterisk use modules asterisk break your code into modules. This helps to encapsulate code and reduce the risk of naming conflicts. Modules are a larger topic, but worth exploring for larger projects. Asterisk be mindful of closures asterisk when using closures, carefully consider which variables are being captured and whether you're capturing them by reference or by value. IIFEs are a common solution. Avoid shadowing. Avoid giving local variables the same names as global variables. It's confusing and prone to errors. Linting tools. Use a linter, like ESLint, to automatically detect potential scope-related issues and enforce coding style guidelines. Debugging scope issues. Scope-related bugs can be tricky to debug. Here are some tips. Careful code review. Read your code carefully, paying close attention to where variables are declared and used. Console logging. Use console.warn and console.error to log variable values at different points in your code. This can help you trace the flow of data and identify where things are going wrong. Debugging tools. Future Bedrock scripting debugging tools are still evolving. In the future, we may have more sophisticated debugging features to step through code and inspect variable values. In summary, understanding scope is essential for writing robust and maintainable Bedrock scripts. By carefully managing variable visibility and lifetime, you can prevent unexpected behavior and create a more stable and predictable Minecraft experience. The bed monsters of accidental globals, closure problems, and naming conflicts are all avoidable with a conscious effort to write code that is well structured and follows best practices for scope management. By avoiding these pitfalls, you'll be well on your way to creating amazing Bedrock experiences.